All right, this is going to be part 2 of the review. So we're starting at number 28. All right, so it says, what is the greatest common factor in the polynomial? So you're going to have to see what each one has in common. So if we look at the numbers first, we have 4, 16, and 8. Now, if you think about a number that goes into those, let's see. The factors of 4, I've got to give it a minute to show up on my board. Okay, the factors of 4 are 1, 2, and 4. 16, 1, 2, 4, 8, and 16. And then 8, we have 1, 2, 4, and 8. All right, so now we need to find the biggest number that they all have in common. If we look, 4 is their biggest number. So 4 is our GCF for the numbers. Now we look at the variables. We have x cubed, x squared, and x. So we take the smallest variable there is. And in this one, it's x to the first, so we're going to take out an x. So we're left with x squared plus 4x minus 2. Because all we're going to do is divide each monomial by the 4x. And that will give us what's left. All right, number 29 is it's a trinomial. So since there's 3 of them, we're going to have to do the x method. Now we have to multiply to get 18 and add to get 9. So our factors of 18 are 1, 2, 3, 6, 9, and 18. Now if we look to see what would give us 9, we have 6 and 3. So 6 and 3. So our factors are going to be x plus 6 and x plus 3. And that's going to be your answer. Now on this one it says, on number 28, looking back at it, it says, what is the greatest common factor? Your greatest common factor is 4x. But you can go ahead and finish out what is left. All right, number 30. Again, we're going to do the x method. So we need to multiply to get negative 24, add to get 2. So if you think about your factors, you have 6 and 4. One of them has to be negative because you have a negative right here. But this is positive. So your 2 is going to take the sign of your bigger number. So that's going to make 4 negative. So your factors are x plus 6 and x minus 4. All right, 31. Again, x method. We get a positive 21 and negative 10. All right, so if you think about your factors, multiplying to get 21, you have 7 and 3. Now, since your 21 is positive and your 10 is negative, then you need to add to get a negative but multiply to get a positive. In order to do that, they both have to be negative. So it's going to be x minus 7, x minus 3. All right, number 32, factor completely. So let's look. The numbers, we have a 5 that'll come out of both of them. And then if we look at the variables, we have p squared and p is our smallest. So if we take that out of both of them, we're left with 2 plus p. All right, the next one. We look at our numbers. It goes into 5 that goes into 7 besides 1. So now let's look at our variables. We have x in both of them, and x is our smallest. So if we take that out of both of them, we're left with 5 plus 7x squared. All right. Now, moving on. Let me see. I think I missed some. No, that's right. Okay. So moving on, it says find all of this. This is where we do p over 2 because we're not given anything. And just so you know, this is x cubed minus 9x squared plus 8x plus 60. All right, so if we do p over q, that's all of our possible roots. And remember, it's going to be plus minus because it's going to be positive or negative. Now remember, our p is always our constant. And our q is always our leading coefficient. So let's do the easy one first. Our factors of q is just 1. Now our factors of 60, 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, and 60. Now, if we do all the p over q's, that means we put all of our p values over all of our q values. That means 1 over 1 becomes 1, 2 over 1 is 2. So we're just going to rewrite these because anything over 1 is going to be itself. But we have the option of having positive and negative in these. All right, now we're going to end up doing synthetic division to find our roots. Remember, our exponent, our biggest exponent, lets us know how many there are. There's 3. So this is just a guessing game now. So we have 1, negative 9, 8, and then we have a 60. So let's go, I said always try 1 and 2 first. So let's go with a negative 2. If I do negative 2, we'll bring down the 1, negative 2. Negative 2 times negative 11 is a positive 22. 8 plus 22 is a positive 30. Negative 2 times 30 is a negative 60. 60 minus 60 is 0. That is our first one. All right. So now let's try another one. All right. With the numbers being as big as they are, I know that it's not going to be 1 or 2 anymore. I'm going to try 5. So 1, that's 5. Negative 11 plus 5 is 6. Negative 6, 5 times negative 6 is negative 30. That gives us 0. There's another one. We have one more left. Here we need a 0. To get a 0, we need a 6. 1 times what gives me 6? Isn't it 6? So negative 2, 5, and 6 are my zeros. And like I said, pick and choose. If you end up getting 0, then it works. If you don't, then you need to try something else. All right, number 35. You've got 4x to the 5th plus 2x cubed plus 2x minus 3. Now, this just says list all possible. It doesn't say find all right? So we're just doing p over q. So remember, p over q is going to be plus minus. This is my q. This is my p. So my factors of p are 1 and 3. My factors of q are 1, 2, and 4. Now I need to put all of my p's over all my q's. So I'm going to put everything over 1. So 1 over 1 is 1, 2 over 1 is 3. Now I'm going to put everything over 2. So 1 over 2 is 1/2. 3 over 2 is 3/2. Now I'm going to put everything over 4. So 1 over 4 is 1/4. And then 3 over 4 is 3/4. And that's all my possible rational zeros. All right. Number 36 is the same thing. Go ahead and try it on your own and see if you get it. That is 7x cubed. Let me rewrite it. 7x cubed plus 3x squared plus 3. All right, remember this is P. This is Q. So I want you to try it. I'm going to go ahead and pause the video. And then once you finish, unpause it and see if you get the same answer. I'm just going to go ahead and give you the answer since I've already done 2 of these with you. But going to be 1, 7, 1/3, and 7/3. That is all your possible. Now, if it said to find them, then you're going to have to do synthetic division. All right, number 37. It says, is 5 a 0 of x cubed minus 7x squared plus 7x plus 15? So we're doing synthetic division. So 1, -7, +7, 15. Now, it's asking us if it's a 0. That means is it a root? Do not pick C, please. Do not pick D. A 0 is an x-intercept. But since it's not giving us a factor, it's asking, we're going to use what it's given us. So 1, 5 times 1 is 5. That gives us a -2. 5 times -2, -10. 7 minus 10 is a -3. 5 times -3 is -15. 15 minus 15 is 0. So our answer would be A, yes. All right. So now, 38, determine the end behavior. So we have 2x cubed. Yes, 2x cubed minus 5x squared plus 1. Now, all we need to look at right here is our exponent. All right? We need to look at what is going on right here. So our exponent is cubed and it is positive. So remember, for this one, it's going to start down and go up. So that's the shape of our graph, and we would graph it. So now it's asking what the end behavior is. So on the left, it is going down, and on the right, it's going up. So A says down to the left, up to the right. That works. B says down to the right. Nope, we already know that's wrong. C says up to the left. No. D, down to the left. Yes. Down to the right. No, because we're not going down to the right. All right? And then none of these. Of course, we already have our option, so it is A. All right. So moving on. So factor completely. And this is the kind that y'all had trouble with. So we had x cubed plus 6x squared minus x minus 6. Now, since there are 4, we're grouping these together. So we're going to group the first 2. We're going to group the second 2. Now, you have to look at each set of parentheses, and you have to take out the GCF in each. So in this first one, my GCF, what I have in common in those, is x squared. When I take out an x squared, I'm left with x plus 6. So I've got the first one done. Now I need to look at the second one. All right? So if I look at the GCF, there's nothing really, but I have a negative out front, and I don't want that. So I'm going to take out a -1. When I take that out, I'm left with x plus 6. Now, when I get to this point and I can't factor my parentheses anymore, I want them to match. And they do. This one looks just like this one. So they look just alike. So that means I've completed it. So one of my factors is going to be the set of parentheses. So x plus 6. Now, the other factor is going to be what is left over. I'm going to take the leftovers, I'm going to put them together, and I'm going to put them in parentheses. So x squared minus 1. Now, look at that to make sure they're both completely factored. Well, if I look at this one, it's not completely factored. X squared minus 1 can be factored down by difference of squares. So x plus 1, x minus 1, and then we're just going to bring this one on down with these. So x plus 6. Now I have it factored completely. All right. Number 40. Evaluate the function h of x is equal to 2x minus 9 if h is 7. So we're going to put in 2 times 7 minus 9. So you have 14 minus 9, which is equal to 5. And that's all those are doing. You're just plugging in for the values. All right, evaluate the function. G of x is equal to x squared plus x. If g is -4, so -4 squared plus -4. So negative times a negative is a positive. So 16 minus 4, which gives us 12. All right. So now, moving on. It says determine the x-intercepts and the end behavior. So you're going to have to do P over Q, and then you're going to have to do synthetic division, and we're going to sketch it. Okay? So if I do P over Q, all my P over Q values, I'm going to go ahead and give you are 1, 2, 4, 5, 10, 20, and 40. All right? If I do synthetic division, I have 1, negative 7, 2, and 40. And I'm going to try negative 2. So 1, that's negative 2, negative 9, that's 18, that's 20, that's negative 40, that's 0. That one works. All right, let me try, since I have a 20 there, I'm going to try 4. So 1, that's 4, negative 5, negative 20, that one works. All right, and since I want to get a 0 here, I have to have 5 here. 1 times 5 is 5. So my zeros are negative 2, 4, and 5. All right, and since it's an x cubed and it's positive, I know that my graph is going to look something like this. All right, now you can plug in numbers to see where your high point is going to be somewhere up here and where your lowest point would be between these two, but I'm just going to kind of do a rough guesstimate. It's going to go up, down, and something like this. So it's going to kind of look something like that. All right, so my x-intercepts, we already know. And they are negative 2, 4, and 5. All right, the other thing it asks for is in behavior. So in behavior, I'm spelling that all wrong. So in behavior is what is happening to my graph on the end. So if I look at it, well, I'm waiting for this to erase. All right. So in behavior, as x goes to negative infinity, y is going down, so it's going to negative infinity. As x goes to infinity, y is going up, so it's going to infinity. All right, on number 43, I want you to try it on your own. Pause the video, try, and then I'm going to go ahead and give you your information for it, okay? So it says we need our end behavior, and we need our x-intercepts. Now, I'm going to go ahead and show you all this before I graph it. My end behavior is a cube, and it's negative, so it's going to start up and come down. So as x goes to negative infinity, y is going to infinity. And as x goes to infinity, y is going to infinity. Or sorry, negative infinity, because it's going down on the right side. All right, then I'm going to factor it out. I have a GCF. I'm going to take out a negative x. When I do that, I'm left with x squared minus 4. That's the difference of squares, x plus 2, x minus 2. And that's negative x. Now I'm going to set all that equal to 0. And I get a 0, negative 2, and a positive 2. So that's my x-intercept. 0, negative 2, positive 2. So let's go ahead and put those on the thing. Now we know that it starts up and then it goes down. Again, you can put something in there to kind of see, but it's going to look something like this. Now, if you didn't do end behavior first, you can see on the left side, it's x goes to negative infinity, y is going up, so it's going to positive. And then as x goes to infinity, y is going down, so it's going to negative infinity. All right, let's go on. Number 44, determine the behavior of the graph. So we have an x to the fourth, so we know it's going to be the W like this, or it's going to be the M. Now you have to look and see. We have a negative out front, So it's going to end up being this one right here. All right, so the left arm is down. That's right. Right arm is up. Wrong. Left arm is down. Right arm is down. There is our answer. So it is B. All right, let's continue on. All right, it says determine all zeros, roots, x-intercepts. So we're just factoring these. What can I multiply to get negative 15 and add to get negative 2? 5 and 3, and this takes the sign of my bigger number, so negative 5. So x minus 5, x plus 3. Now these are my factors, but it asks for x-intercepts or roots. So I'm going to set them equal to 0, so 5 and negative 3. All right, determine again. Now this one is the one where you take and you multiply the first and the last, so that's 24, or negative 24. Okay, and then we have to add to get a negative 5. So your factors of 24 are going to be 8 and 3. Now, this takes the sign of my bigger number, so negative 8. Now, the only issue with this one is we have to have a number up front. So we're going to have to divide both of these by the beginning number. And we'll simplify them. So 8 over 6 is going to simplify to 4 over 3. And it's going to be negative. And then 3 over 6 is going to simplify to 1 over 2. Okay? So I have, and remember this number will go out in front, and this number will go out in front. So I have 3x minus 4, and then 2x plus 1. Now, of course, I got to set them equal to 0. So if I do that, I'm going to get x is equal to 4 over 3, and x is equal to negative 1 over 2. So really, I already had them in my factors. I just changed my sign. All right, number 47. Identify the domain of the rational. Remember, the domain comes from my vertical asymptote, so I need to find that. My vertical asymptote, I have to set the bottom equal to 0, but I need to factor first. So on the top, it's already factored, x minus 2. On the bottom, I can take out a 2, so x minus 2. All right. I'm sorry, x plus 2 is what that should be. Now I'm going to set the bottom equal to 0 since nothing cancels, and I have a vertical asymptote at x is equal to negative 2. So it's all real numbers except negative 2. All right, 48. Identify the vertical asymptote. Again, this is already factored. It's x minus 3 and x plus 5. Set the bottom equal to 0. We set it equal to 0. Sorry, that should be an x. So x plus 5 is equal to 0. Subtract 5. And x is equal to negative 5. So that's our vertical asymptote. All right, number 49. Find the horizontal asymptote. So we're just looking at our exponents. We have a 1 here and a 2 here, so the bottom is bigger. We have a horizontal asymptote at 0. All right, identify the x-intercept. So that is going to be 5x minus 15 over 3x. So on the top, we can take out a 5, and we're left with x minus 3. And on the bottom, it's 3x. All right, so since we can't cancel anything out, for the x-intercept, we set the numerator equal to 0. So x minus 3 is equal to 0. And that's going to give us x is equal to a positive 3. All right, and then the last one we're going to do for this section, we're going to find the x and y intercept, the asymptotes and all, okay? So y, x, horizontal, which goes with my range, vertical goes with my domain, and then we're going to see if we have any holes. So we look to see if we can factor anything. On the top, we can take out a 2. So we're left with x plus 4. On the bottom, we're an x. Nothing cancels out, so there is no hole. So we would put none. All right, let's look at our y-intercept. If we plug 0 in here and a 0 in here, it gives us 8 over 1. So our y-intercept would be 8. So y is equal to 8. All right. Now, our horizontal asymptote, we look at our exponents, and I'm going to erase where I wrote over with a 0. We have a 1 and we have a 1. So since they're the same, we take our ratio. So 2 over 1. 2 over 1 gives us a 2. So we have a y-intercept, or a horizontal asymptote at 2. So our range is going to be all real numbers except 2. All right, now, x-intercept, we set what's on top equal to 0. So if we do that, we set this equal to 0, x plus 4, it gives us -4. Vertical asymptote, we set what's on bottom equal to 0. X is equal to 0, so we have a vertical asymptote at 0. So our domain is all real numbers except 0. Now let's graph it. So we have a vertical asymptote at 0, which is on, and I'm just going to dot this so you can see it, which is on our y-axis. And then we have a vertical asymptote at 2, horizontal, at 2. Okay, now let's plot our points. So we've done this one, and we've done this one. We don't have to worry about the domain and range, and we don't have a hole, so we're good there. All right, so y-intercept. We can't have a y-intercept if we're actually graphing because there is a horizontal asymptote, vertical asymptote, sorry. All right, but we do have an x-intercept of -4. So let's go ahead and plot that. Now, if we're looking at this, we look at this side of the graph. Since our x-intercept is at -4, our graph is going to be on the bottom. So we just sketch it. Now, if we're looking at the right side of the graph, since there's not an x-intercept, it's going to be on the top. And there you go. Now, that's the last one that's going to be on this section of the video. You'll have one more part that will take care of the rest of the review.